All right, so I'd like to do one more problem from the book. And then I'd like to do a couple examples just to walk you through off of those sheets, and then hopefully there'll be a few more minutes and you can do some more practicing. Okay. So I'd like to do page 343, number 66, which is a definite integral, which means it has limits, but we can still use the u substitution that we've been using to solve the problem. Okay. So in this one, it's actually important that you know what the directions say. So would someone read the directions, please? Okay, and what's our integral then? 0 to 2. Good. Okay. So what's the first thing you ask yourself when you come to an integral? Yeah, do I know what the antiderivative is just by looking at it? I would actually call it like inspection. Can I solve it by inspection? Just by looking at it, do I go, oh wow, the integral of x is x squared over 2? No. So what's the only other tool I have in my toolbox right now? U substitution. So where do I look for u's? Denominators. Where else? Something that's raised to a power. The square root of something. The argument of a trig function. Whatever's in parentheses. Whatever the e is raised to is another good place to look for things. There's a couple examples like that we'll do. Can be a u as well. And I think, actually, I didn't choose one of those, but there are some of those on here. And in fact, we could do one. Maybe. We'll do one of those. Okay. So, what situation do I have here? A denominator. So what am I going to let u be equal to? 3 plus e to the x. All right. So Rebecca, what's du going to be? Nope, because the 3 is a constant, right? So when I take the derivative of 3, what do I get? 0. No, because what's the derivative of x? 1. Okay, so you're right to think about the chain rule. You're right to think about what that exponent is, but the derivative of the exponent is 1 in this case. Okay. So this one's pretty good because whatever's down here is going to be u, and looky, what's in the denominator is du. So I've got very little algebra here. Now, when you're doing a definite integral, you need to think about the limits. And there are two ways to do this. Okay? One way to do this is to figure out what u of a is and u of b is, and then make this the integral. In this case, it would be du over u of a to u of b. Okay? And then you would evaluate the integral, you'd substitute in the upper limit, minus substitute in the lower limit, and you'd end up with a numerical value. Okay? That's one way to do it. The other way to do it, which is the way I like to do it, but it doesn't matter, it'll get you to the same place, and we'll do it both ways. What I like to do is say, I'm going to leave my x limits, but my integral is du over u. And what's the antiderivative of du over u. Or what's the integral of du over u? Natural log. But remember that these limits are x values. So for me, in the years that I've done this, what I always do is I always substitute back in for u anyway, because I would certainly, if it was an indefinite integral, I would never leave my answer in terms of u. So I substitute back in for what u is. My limits are in terms of x, so then it's going to be the natural log of 3 plus e to the 2 minus the natural log of 4. Which has some value. Go ahead, figure it out, because it is in fact just a number. What'd you get, Gianni? Okay. What's the next digit? Okay. Thank you. Everybody else? That's what we get? Okay. So, like I said, that's the way I would do it, but you need to remember to substitute back in for u before you evaluate the limits. The other way to do it, like I said, is to figure out what u of a is. So that's going to be u of 0. U is 3 plus e to the x. So that would be 3 plus e to the 0, which gives me 4. And then I take u of 2, which is going to give me 3 plus e squared. Okay. So my integral becomes the integral from 4 to 3 plus e squared of du over u. But now remember that these limits of integration are in terms of u. So what's the integral of du over u? ln of u still. My limits go from 4 to 3 plus e squared. I get the natural log of 3 plus e squared minus the natural log of 4, which is in fact what I had up here. So it should still be equal to 0.954, because it's not even like we're getting it another way. So you can do whatever makes you comfortable. Whatever you think you are least likely to make a mistake of doing. I don't care. But you need to pick a way and do it and be consistent and do it right. If you can't pick a way to do it, I'll pick a way for you in a lovely little one-on-one meeting. Okay, so we got it? It makes sense? Okay, then I'd like to try another couple examples off the sheet. What was I going to do? Because Casey, where did it go? It wasn't that. It wasn't that. Oh, here, like we could do number 2. which is the integral of 36x squared e to the 4x cubed plus 3. I'm on one of the sheets that has 7.2 on it. It says integration by substitution. It looks like this. Number 2, but there are a lot of number 2s. This wasn't the one that was really cool. I was going to do something else. Because I don't like it when they give you the substitution. I like it when you have to figure it out for yourself. Because I think that's, you know. Oh, that's what I was going to do. I don't want to do that one because they give you the substitution. I want to do number 8 on that same page, which is the integral of 5 e to the negative 3 plus the natural log of 3x all over x dx. Okay, it's just further down that column. And really it doesn't matter because you can just write it in your notes. Okay, so we're back to an indefinite integral, so we'll have that plus c at the end. And so I've come to an integral. What's the first thing I ask myself? Do I know what the antiderivative is just by looking at it? Can I solve it by inspection? No. So what's the only other tool we have in our toolbox right now? Substitution. Okay, so where do I look for u's? The denominators, I got an x down there. We'll see. Exponents of an e, I got one of those. Where else do I look? Under a radical, something raised to a power. What's in parentheses? One more. The argument of a trig function. Okay. I ask you to repeat it every time for a reason so that you remember what you're looking for. Okay. So what do you think we should go with here? Yeah. Okay. So remember that one of the things, one of the purposes behind u substitution is you're trying to make the integral look easier. You're trying to make the integral into something that you can solve by inspection so that you could look at it and go, oh, that's natural log. I got that. Or, oh, that's cosine. So if there's something complicated in there, that's probably what you want your u to be. Okay? So if we let u be negative 3 plus the natural log of 3x, then du is going to be what? Well, okay, so the derivative of negative 3 is, the derivative of a natural log is, but I've got my chain rule, right? So it's 1 over whatever I'm taking the natural log of, but if I'm taking the natural log of anything other than x, I have to take the derivative. And so those 3's will, there should be a dx there. Those 3's will cancel, and I'll get dx over x. Thank you. So now you want to go back up and look. So we know that this is going to be u. Do I have du up there somewhere? Yeah, I have my dx over x. So this is going to give me du. And then I want to rewrite my integral. So I can just pull that 5 out, right? I don't really need it. Times the integral of e to the u du, right? And then what do I get when I take the integral of e to the u du? Well, the 5's out there, but I asked you. The answer to the question I asked is e to the u, which is what you gave. We just have the 5. And then what do we have to have, though? Plus c, because it's not a definite integral, it's an indefinite integral. And then what's the last step? I have to substitute back in. So that's going to be negative 3 plus the natural log of 3x plus c. And seriously, that's annoying me to no end. Because what can I do here? I can make it 5 e to the negative 3 e to the natural log of 3x plus c, right? So that's 5 e to the negative 3, but what does this become? 3x. So this becomes 15 e to the minus 3 because that's just a number, x, not plus 5. Being a little presumptuous with what my constant is. Okay? I take you that extra step of algebra because sometimes on the AP exam, you'll get this answer and that won't be there. This one will be. And you have to know, you have to be ready, you have to be comfortable with saying, okay, I could manipulate this and turn it into something else that looks like what I have. Okay? All right, we good? I'd like to do, well, we did that, and that's kind of like what that was. Let's try one more. This is on the other sheet that says 7.2 integration by substitution, and it's on the back, and it's number 14, and it's the integral of e to the 4x minus 4 to the 1/5 times e to the 4x dx. So remember that the point of u substitution is to make the integral look easier. It's to make it look simpler. It's to make it be recognizable. Okay? So, what's the first thing I do when I come to an integral? Can I solve it by inspection? Do I know what the antiderivative of that is? Holy cow, no. So what's my only other tool in my toolbox right now? Substitution. Okay, where do I look for substitutions? Inside the parentheses. Okay, is it freaking anybody out that there's an e to the x in here and an e to the x out there? Okay, here's why it shouldn't freak you out. What's the give me something that's in the derivative of e to the 4x. E to the 4x. So if I'm going to make this be my u, when I take the derivative of that, my du has to have an e to the 4x in it. So actually the fact that this factor is over here should be reassuring because you're going to need it later and it was provided to you. So let's take what's inside our parentheses that's raised to a power. And then what's du going to be? What? Right, because I have to take the derivative of my exponent, right? Yes, it is. I told you it would be. Omniscient narrator. Everybody knows what that means, right? What omniscient means? All-knowing. I like to be omnipotent too, which is all-powerful. So this part here is my u. What's this part? 2 du. Very good. Yes. So we can rewrite this And I do have this extra factor of 2 that I can bring out front. So I've got u to the what? 1/5 times du. Can you solve that by inspection? Yeah, it's power rule, right? Or inverse power rule, or whatever you want to call it. Sarah, are you okay? Yeah, okay. You had a funny look on your face, like you didn't understand where what I had done had come from, so just want to make sure. That's okay. It's a slow day. I hear you. All right, so I'm going to keep my 2 out here. What's the antiderivative of u to the 1/5? Well, divided by 6/5. I have to divide by the whole new exponent. Okay. And what did I forget? Plus c. Good. And then I'm going to do some algebra that'll freak somebody out. Yeah, it usually is. And I just substitute back in for u. Check, but I'm pretty sure I did the fraction right. Thanks, Penny. So, this is the first tool in your toolbox. Tomorrow we will learn a new tool in your toolbox. I highly recommend that you practice using this one for a while. Okay? So that you understand how this one works before we add integration by parts tomorrow, which again is going to freak you out. That's the way it works. Okay? So you've got 5 minutes, 4 minutes, practice another couple. Okay? Because then at least I will know you will have practiced some, because I know that your lives go on when you leave my presence.